The concept of a jungle, specifically the tropical rainforest, begins not with the first tree, but with a celestial accident of perfect proportions. Earth's tilt and orbit create the tropics, a belt around the equator where sunlight strikes directly year-round, delivering not just light, but immense thermal energy. This energy is the engine. It heats the ocean's surface, particularly in the Indo-Pacific warm pool, causing water to evaporate at a phenomenal rate. This isn't gentle steam, it's the atmospheric fuel for the planet's greatest rainfall machine. The trade winds, those consistent easterly flows, capture this moisture-laden air and sweep it across continents. When this marine air mass meets a land mass, like the Andes in South America or the highlands of Central Africa and Southeast Asia, it is forced upwards. As it rises, it cools, and the water vapor condenses into clouds and eventually torrential rain. This cycle isn't occasional. It's a daily conveyor belt, a hydrological heartbeat that can dump over 100 inches of rain in a single location annually, with some areas like Sherry-Punji in India or parts of the Amazon receiving over 400. This constant deluge, combined with consistently warm temperatures averaging between 70 and 85 degrees Fahrenheit year-round with minimal fluctuation, creates the first fundamental condition, a climate of relentless growth and decay. There is no winter dormancy here, no pause. The metabolic rate of the ecosystem is turned to its maximum. This heat and water catalyze chemical reactions in the soil and in living tissues at an accelerated pace. But here lies the first great paradox of the rainforest. Its breathtaking fertility is a magnificent illusion. The soil beneath that unimaginable green wealth is often profoundly poor, thin, and acidic. The torrential rains that give life also leach it away, washing soluble nutrients like nitrates, phosphates, and potassium, the very building blocks of life, deep into the groundwater, out of reach of plant roots. So if the soil is a nutrient desert, how does this cathedral of life stand? The answer is in the architecture itself. The rainforest has evolved to create its own closed-loop fertility system in the air. Up to 90% of the nutrients are not in the ground at all, but are locked in the living biomass, the trees, vines, epiphytes, and animals. When a leaf falls, a branch breaks, or an animal dies, the decomposers swarm. This is where the true magic happens. A legion of organisms unseen to the casual observer works at a breakneck speed. Fungi, from microscopic threads to vast mycelial networks, are the primary chemists secreting enzymes that break down tough lignin and cellulose. Termites, ants, beetles, and a universe of bacteria join in. A leaf that might take a year to decompose in a temperate forest can be recycled in under 6 weeks here. The resulting nutrient soup is immediately, ruthlessly captured. A mat of fine, superficial roots lies just beneath the leaf litter, a voracious network operated primarily by the trees themselves and their fungal partners, called mycorrhizae. These fungal filaments act as extensions of the root system, vastly increasing their surface area and efficiently scavenging every released ion of phosphorus, every molecule of nitrogen, before the rain can steal it away. This creates a hyper-efficient, above-ground nutrient cycle. The forest feeds itself from its own canopy downwards, a tight, almost miserly recycling program that leaves little to enrich the actual earth. This is why, when the forest is cleared, the apparent richness vanishes. The system is broken. The nutrient capital is spent or washed away in a few harvest cycles, and what remains is often incapable of supporting sustained agriculture, leaving behind a hard, red, lateritic clay. This fundamental understanding shatters the pioneer's dream of fertile jungle soil. The fertility is in the living structure, a precarious, self-sustaining vault held aloft by trunks and branches. This leads to an intense, silent war for light, the second currency of this world. With nutrients so efficiently recycled and generally evenly distributed, the limiting factor becomes sunlight. The primary strategy is vertical layering, a stratification of life into distinct zones. The emergent layer, giants towering 200 feet or more, are the skyscrapers, their crowns forming a discontinuous, sun-drenched canopy in the sky, battered by wind and bearing the full force of the sun. Below them, the main canopy, a continuous roof of greenery 60 to 130 feet high, is the engine room of the forest, capturing an estimated 80% of the available sunlight. This dense ceiling is so effective that it creates the next layer. The understory, a world of perpetual twilight, where plants have evolved large, dark green leaves to absorb the scarce photons that filter through. Finally, the forest floor, receiving a mere 1 to 2% of the sunlight, is a realm of shadows where decomposition rules and seedlings wait in patient dormancy for a gap, a literal light gap to be created by the death of a giant. This relentless competition for light drives incredible adaptation. Buttress roots that act as flying buttresses to stabilize shallow-rooted giants in thin soil, cauliflower, where flowers and fruits grow directly from the trunk to be accessible to pollinators and dispersers in the dim understory. And the race to grow fast and straight, sacrificing side branches to reach the light. This is a world where stillness is a strategy for some and explosive growth for others, all governed by the economy of light and a recycling program of miraculous efficiency. Moving from the architectural and chemical genius of the forest structure, we descend into the realm of its inhabitants, where the evolutionary arms race has produced a theater of specialization and interdependence, so intricate it borders on the absurd. Biodiversity here isn't just a number, it's a hyper-specialized web where every niche, every microhabitat is occupied by a life form fine-tuned to exploit it. Consider pollination. In temperate forests, wind or generalist insects like bees often do the job. Here, that's too inefficient. In the crowded, competitive canopy, plants have evolved to recruit specific, reliable partners. The classic example is the orchid, with over 25,000 species in the tropics, many of which have flowers that mimic the scent, color, and shape of a specific female insect to lure in amorous males, who then unwittingly carry pollen. Some fig trees are pollinated only by a single species of tiny wasp, a relationship so exclusive that the tree's life cycle and the wasps are perfectly synchronized. Neither can survive without the other. This principle of specialization extends to seed dispersal. Fruits are not just colorful and fleshy, they are tailored messages. Bright red or orange fruits often attract birds who have excellent color vision. Fruits that are odorless by day but emit a strong, musky scent at night are targeting bats or nocturnal mammals. The massive, hard-shelled durian fruit, for instance, is designed to be eaten and dispersed by large mammals like elephants and rhinoceroses, its infamous smell a beacon to them. But the relationships go deeper than simple trade. Ants, perhaps the dominant animal group in the rainforest by biomass, form alliances with plants. Acacia trees in the no-tropics house and feed colonies of vicious ants in their hollow thorns in return. The ants swarm out to attack any herbivore, vine, or competing plant that touches their host, serving as a living, breathing defense system. This is a paid, standing army. Similarly, some species of caterpillars have ants that tend them, protecting them from parasites in exchange for a secretion of sugary honeydew. The communication within this web is a constant, unseen chatter. Plants, under attack by herbivores, don't just sit idly by, they release volatile organic compounds in the air, chemical distress signals. These signals can be picked up by neighboring plants of the same species, prompting them to preemptively ramp up their own chemical defenses. Even more astonishingly, these signals can attract the specific predators of the herbivores attacking them. A bean plant chewed on by a mite will release a compound that attracts predatory mites that feed on the herbivorous ones. The forest is literally talking, conducting chemical warfare, and sending out calls for mercenaries. This leads to the phenomenon of coevolution, a dance where the evolution of one species directly influences the evolution of another. The long, curved beak of a hummingbird is perfectly matched to the long, curved corolla of the heliconia flower it feeds from. The slightest change in the flower's shape selects for change in the bird's beak, and vice versa, in a perpetual, intimate tango. This specialization creates an ecosystem of immense stability, but also profound fragility. Remove one specialized pollinator or disperser, and its partner plant may vanish, triggering a cascade. This biodiversity is also a vast, untapped pharmaceutical library. An estimated 25% of modern medicines are derived from rainforest plants. Yet less than 1% of these plants have been studied by science. The treatment for childhood leukemia came from the rosy periwinkle of Madagascar. Compounds from poison dart frogs are being studied for painkillers 200 times more potent than morphine without the addictive properties. The next cure for a pandemic, the next breakthrough in neurology could be in the bark of a tree that has yet to be cataloged. Yet, this same specialization makes species incredibly vulnerable to disturbance. A frog that lays its eggs exclusively in the tiny pools of water held in bromeliad plants high in the canopy is doomed if logging or climate change dries out the canopy microclimate. The intricate timing between fruiting seasons and the migration patterns of animals can be shattered by shifting weather patterns. This layer of the rainforest reveals it not as a collection of species, but as a single, pulsating organism, a network of millions of conversations, contracts, and chemical signals, where every life form is a sentence in a story of survival written over millions of years. A story we are only beginning to decipher, and one we are carelessly ripping pages from. To perceive the rainforest as merely a collection of exotic species or a distant green paradise is to fundamentally misunderstand its role on the planetary stage. It is, in fact, one of Earth's most critical and active geophysical organs, a regulator of global systems without which the climate of our planet would be unrecognizable and largely uninhabitable for humanity. The first and most vital function is its role in the carbon cycle. These forests are colossal carbon sinks. Through photosynthesis, they absorb billions of tons of carbon dioxide from the atmosphere annually, locking the carbon away in their wood, leaves, roots, and the surrounding soil organic matter. The Amazon alone is estimated to store between 150 and 200 billion metric tons of carbon equivalent to more than a decade of global human-caused emissions. This isn't a passive storage unit, it's a dynamic, living buffer against climate change. However, this relationship is a double-edged sword. When forests are healthy and growing, they are a net carbon sink. But when they are degraded, burned, or cleared, they become a massive carbon source, releasing centuries of stored carbon back into the atmosphere as CO2 and other greenhouse gases like methane. Deforestation and forest degradation are now estimated to contribute between 10 to 15% of annual global greenhouse gas emissions, more than the entire global transportation sector. This transforms the rainforest from a climate stabilizer into a climate change accelerator in a terrifying feedback loop. Climate change causes droughts and increased fire risk, which leads to more forest loss, which releases more carbon and causes more climate change. The second planetary function is the creation of rivers in the sky. This is perhaps the most mind-bending concept. The vast evaporation from the rainforest canopy a process called transpiration, where each tree acts like a giant water pump, pulling moisture from the ground and releasing it as vapor through its leaves contributes directly to atmospheric moisture. This moisture doesn't just fall locally. It is carried by prevailing winds, creating aerial rivers of vapor that travel continental distances. The Amazon, for example, generates approximately 20 billion tons of water vapor per day. This flying river is crucial for rainfall patterns across South America, nourishing the agricultural heartlands of Argentina, Paraguay, and southern Brazil. The grain baskets of continents are watered by forests hundreds or thousands of miles away. Disrupt the forest, and you disrupt the hydrological pump, leading to decreased downward rainfall, prolonged droughts, and catastrophic impacts on food production for millions. The third function is climate regulation through albedo and convection. The dark green canopy of the rainforest has a low albedo, meaning it absorbs a high percentage of solar radiation. This absorbed energy heats the air, causing it to rise and creating low-pressure zones that draw in moist air from the oceans, sustaining the rain cycle. Replacing this dark forest with lighter-colored pasture or cropland increases the Earth's albedo locally, reflecting more sunlight, which can have complex cooling and warming effects, but fundamentally alters wind and rainfall patterns. Furthermore, the forest's immense transpiration acts as a natural air conditioning system, releasing energy through the latent heat of vaporization, which helps moderate regional temperatures. The fourth, less visible function is as a biodiversity bank and evolutionary cradle. Over 50% of the world's known plant and animal species reside in these forests, which cover only about 6% of the Earth's land surface. This isn't an accident of geography, but a result of the stable, warm and wet conditions over geological time, allowing for uninterrupted evolution and speciation. They are engines of genetic diversity, the raw material for adaptation and resilience in the face of environmental change. Finally, rainforests play a critical role in nutrient cycling on a global scale. While they hoard nutrients internally, they also export them. Rivers flowing from rainforests, like the Amazon, carry dissolved organic matter and sediments thousands of miles into the oceans. This nutrient plume feeds phytoplankton blooms that form the base of marine food webs and even influences ocean chemistry and currents. The rainforest, therefore, is not an isolated biome. It is a central hub in the Earth system, intricately linked to the atmosphere, the hydrosphere, the geosphere, and the biosphere. It is a thermostat, a water pump, a carbon vault, an evolutionary laboratory, and a nutritional link to the sea. Its fate is not a local environmental issue. It is a direct determinant of global climate stability, food security, and the continued existence of a majority of Earth's terrestrial life forms. A fact that places its conservation squarely in the realm of global geopolitical and economic necessity, not merely ecological sentiment. The majesty and global necessity of rainforests stand in stark, sober in contrast to the relentless forces arrayed against them. The primary driver of deforestation is not malice, but a complex web of economic incentives, poverty, and global market demands that transform living ecological capital into short-term financial gain. The largest cause globally is agriculture, accounting for around 80% of deforestation. This is not a monolithic force, but operates at different scales. At the industrial scale, vast swathes are cleared for cattle ranching, particularly in the Amazon. Brazil is the world's largest exporter of beef, and much of this production is directly linked to forest conversion, often through a cycle of illegal logging, followed by burning, followed by pasture establishment. The second major industrial driver is the cultivation of commodity crops, primarily soybeans and oil palm. While soy was once a major direct driver in the Amazon, moratoriums have reduced its impact there, but it pushes ranchers deeper into forest frontiers, a phenomenon called indirect land use change. The true epicenter of industrial oil palm expansion is Southeast Asia, particularly Indonesia and Malaysia, where ancient, biodiverse peatland forests are drained and burned to create monoculture plantations for palm oil, an ingredient found in nearly half of all packaged supermarket products, from cookies and shampoo to biofuels. This conversion is doubly catastrophic, as draining and burning carbon-rich peat soils releases staggering amounts of CO2. Beyond these giants, there is small-scale, subsistence agriculture, often driven by landlessness and poverty. Farmers may use slash and burn techniques, clearing a few acres to feed their families. While the individual footprint is small, the cumulative impact of millions of such farmers is immense. Logging, both legal and illegal, is another critical driver. Selective logging for high-value timber like mahogany, teak, and pine opens up previously inaccessible forests by creating road networks. These roads are the arteries of further deforestation, providing access for miners, settlers, and ranchers. Mining for gold, bauxite for aluminum, copper, and coltan for electronics scars the landscape, leaches mercury and other toxins into waterways, and often operates in remote protected areas with devastating local impacts. Infrastructure projects, hailed as development, are often the death knell for large, intact forest tracts. Massive hydroelectric dams like the now canceled São Luís do Tapajós Dam in the Brazilian Amazon would have flooded hundreds of square miles of forest, displaced indigenous communities, and emitted methane from rotting vegetation. Roads like the proposed Pan-American Highway through the Darien Gap or the expansion of the BOR 319 highway in the Amazon open Pandora's box, facilitating all other destructive activities. The underlying enabler of much of this is weak governance, corruption, and unclear land tenure. In many rainforest nations, land titles are contested or non-existent, leading to land grabbing by powerful interests. Environmental agencies are often underfunded and their personnel threatened. In 2022, the Amazon region saw record numbers of murders of environmental defenders. Illegal activities frequently operate with impunity. The global economic system externalizes the true cost of deforestation. A cheap hamburger, a bar of soap, or a new smartphone does not reflect the cost of lost biodiversity, released carbon, or disrupted rainfall patterns. This creates a perverse subsidy for destruction. Furthermore, climate change itself is now a direct threat, acting as a multiplier of these existing pressures. Increased temperatures, altered rainfall patterns, and more frequent and intense droughts, like those associated with El Niño events, stress giant trees, make forests more flammable, and lead to widespread tree mortality. The Amazon is perilously close to a potential tipping point where so much forest is lost that the remaining system can no longer generate enough rainfall to sustain itself, triggering a large-scale irreversible dieback and transformation into a savanna-like ecosystem. This isn't speculative fiction. Leading climatologists like Carlos Noble have warned that the deforestation threshold for this catastrophic shift could be as low as 20 to 25% of the original forest cleared. We are currently at around 17% in the Amazon. The consequences of crossing this line would be a regional and global calamity, releasing tens of billions of tons of carbon, collapsing biodiversity, and devastating South American agriculture. The assault on rainforests is thus a multi-front war, waged by chainsaws and bulldozers, fueled by global consumption, enabled by failed policies, and exacerbated by a changing climate. It is a race between the forces of extraction and the ecological thresholds of resilience, a race whose outcome will define the habitability of our planet for centuries to come. Confronted with the scale of the challenge, it is easy to succumb to despair, to see the loss as inevitable. But that narrative is not just defeatist, it is factually incorrect. Solutions exist, they are multifaceted, and they range from the global to the hyperlocal, from technological innovation to the wisdom of ancient custodians. The most straightforward and urgent solution is to protect what remains. This means not just creating protected areas on paper, but effectively funding and managing them, supporting the guards and rangers who risk their lives on the front lines. It also means formally recognizing and securing the land rights of indigenous peoples. A study after study has shown that forests under the stewardship of indigenous communities are the best preserved. These communities are not conservationists by Western NGO definition. They are the forest, their identity, culture, and survival intertwined with its health. Supporting their territorial claims and self-determination is not just a moral imperative, it is the single most cost-effective climate and biodiversity strategy available. The second pillar is sustainable use and economic alternatives. If standing forests are to compete with cleared land, they must generate economic value. This includes promoting and certifying sustainable forestry under schemes like the Forest Stewardship Council (FSC), which, while imperfect, sets a higher bar. It includes developing markets for non-timber forest products, fruits like acacia and cane, nuts like Brazil nuts, resins, and medicinal plants that provide income without destroying the canopy. Perhaps most promising is the potential for payments for ecosystem services (PES). The concept is simple. The global community pays rainforest nations and communities for the services their forests provide: carbon storage, water regulation, biodiversity conservation. This is the principle behind international mechanisms like REDD+, reducing emissions from deforestation and forest degradation, though its implementation has been fraught with complexity and concerns over equity. More direct, corporate-led carbon credit markets are emerging, where companies offset their emissions by funding forest conservation projects. While these must be rigorously monitored to ensure they represent real, additional, and permanent emission reductions, they channel finance to where it is needed. On the consumer end, demand-side pressure is powerful, choosing products certified as deforestation-free. For palm oil, soy, beef, leather, cocoa, coffee by credible organizations sends a market signal. Reducing meat consumption, particularly beef, directly reduces pressure on forests for pasture. Holding corporations accountable through shareholder activism and supporting legislation that bans the import of commodities linked to deforestation, like the EU's recent deforestation regulation, are critical steps to clean up global supply chains. Technological innovation is a powerful ally. Satellite monitoring, like that provided by Global Forest Watch, provides near real-time alerts on deforestation, enabling rapid response. Drones are used for mapping, seeding, and monitoring. DNA barcoding and isotope analysis can trace timber and agricultural products back to their precise origin, fighting illegal logging. Blockchain technology is being explored to create transparent, tamper-proof supply chains. On the ground, agroforestry integrating trees with crops and livestock, and silvopasture combining trees with pasture can restore degraded lands, improve soil health, and provide income while storing carbon. Finally, and fundamentally, there is the need for a paradigm shift in how we value nature. Our entire economic system treats nature as an infinite, free resource to be exploited. We must move towards an economy that recognizes natural capital, the stock of forests, oceans, and wetlands, and the flow of ecosystem services they provide. This means reforming government subsidies that encourage deforestation, like tax breaks for cattle ranching, and redirecting that finance towards restoration and sustainable practices. It means educating a new generation to understand ecological interconnectedness, and it requires unprecedented global cooperation. The fate of the Amazon is as crucial to a farmer in India reliant on stable monsoons as it is to a city dweller in São Paulo. Climate finance for historically high-emitting nations to forest-rich developing nations is not charity. It is a strategic investment in planetary stability. Reforestation and restoration of degraded lands are also vital. While planting a tree is not a simple substitute for preserving an ancient, complex ecosystem, large-scale restoration efforts can help rebuild connectivity between forest fragments, sequester carbon, and restore some ecological functions. The task is immense, but the path is clear. It requires linking the arms of the indigenous guardian, the data of the satellite analyst, the policy of the legislator, the capital of the impact investor, and the choice of the conscious consumer. It is about moving from seeing the rainforest as a warehouse of resources to recognizing it as the foundational infrastructure of our civilization. So, what is the single most important thing you can do after absorbing these 5,000 words? The answer is to move from passive viewer to active participant. Start today. First, make your consumption a vote. Download an app like the Sustainable Palm Oil Shopping app or look for the RSPO label. Choose certified deforestation-free coffee and chocolate. Reduce your weekly meat intake. Second, use your voice. Share this video. Talk about the flying rivers and the indigenous guardians at your dinner table. Write to your favorite brands and ask them to guarantee deforestation-free supply chains. Support organizations on the front lines, whether they are legal groups defending indigenous land rights, like the Amazon Conservation Team or Survival International, or monitoring networks like Global Forest Watch. Third, think globally and politically. Support policies and politicians in your country that push for strong due diligence laws on imported deforestation and that champion increased climate finance for forest conservation. The jungle is not just over there. Its breath is in the oxygen you just inhaled. Its pulse in the climate that grows your food. Its fate in the choices you make every day. This isn't about saving trees. It's about preserving the fundamental operating system of our planet. The story is still being written, and you hold the pen. Subscribe for more deep dives into how our world works. Hit the bell so you don't miss our next investigation into the ocean's twilight zone. And in the comments below, tell me one product you'll investigate or one habit you'll change this week. The time for wonder is over. The time for action is now.